Hey everyone, today I'm going to go over the dot product. And the dot product is just the idea if you take A and you're dotting it with some vector B. These are both vectors. Before I go over how to calculate this, first I'm going to talk about how the values of the dot product align with the geometry in linear algebra. Let's say you do A dotted with B and you get a value greater than 0. That means that vector A and vector B form an angle that's less than 90 degrees. That means that they point in pretty similar directions. Now, what if it's equal to 0? What if A dotted with B is equal to 0? That means that A and B are going to be perpendicular angles. And this is very useful in a lot of applications if you get the dot product to be 0, because you find that the two vectors would be perpendicular, but also in 3D and more, that means that the vectors are orthogonal to each other. Let's say A dotted with B is less than 0. That means the angle is pretty much obtuse or almost in opposite directions. It could be like this too. And all that means is that A and B are pretty much not similar at all. Now let's go over how to calculate the dot product. So let's say I have A is equal to maybe 5, 6, and 2. And B is equal to 1 times 2 times 3. Well, you take this first component and multiply it by the first component in B. So you do 5 times 1. Then for our second component, I'll do this in red, you do 6 times 2, and you add that next. Lastly, you would do 2 times 3, and then you add these all together. So that would be 5 plus 12 plus another 12. And then the answer, that would be 29, I believe. Yes, it would be 29. So as you can see, these two vectors give me a positive number. So what information can I get from that? That A and B might look something like this. The problem with the last equation is that we don't know how similar A and B were because all we got was the number 29. But of course, numbers can go until infinity. So does that mean they're actually not that similar at all? That's where the cosine similarity formula that utilizes the dot product comes into play here. It states that the cosine of theta is equal to A dotted with B times the magnitude of A, which is kind of like the length of the A vector, times the magnitude of B. And if we have our vectors A and B, we know their components. That means that we can solve for cosine of theta. And then we can solve for theta. And what this means is that now we can get the actual angle between A and B if we have A and B available to us. So we said that if the dot product of two vectors are 0, let's say A and B are 0 in this case, that means cosine of theta is equal to 0 divided by something, right, which is just 0. And to get cosine of theta to equal 0, well, theta has to equal 90 degrees. And that confirms that if A and B, their dot product is 0, then these two vectors are perpendicular or in 3D space would be orthogonal to each other. So that's a pretty useful fact too. And since we can now get the concrete angle, this gives us a better idea than what the number 29 or maybe 37 would give us if we just took the dot product of these two vectors. By using this formula over here, we can get the angle between them. I hope you enjoyed this video, and I'll see you in the next one.